We have sort of like a quiz sort of in a couple days, and then next week is like the real like final. But either way, it's the same information, and I just have just a couple different subjects to go over with you.
Okay. Is it
So
stuff you can verbalize?
yeah, of course.
Okay.
The first one is using synthetic division to determine the factors of a polynomial.
Okay.
So I have an equation here. It is, or a function, f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8 when x equals 3.
No x squared term?
No.
Okay. So when you're evaluating this function, when x equals a certain thing, you write it like this.
Okay.
That's what f of 3 means.
Got it.
So that's all we're going to do. And never try to do this math more than one step at a time. So I'm going to write it like this. In other words, just do the substitution, and then we'll go through the next step, and we'll simplify.
Okay.
Everything's in numbers. Now, what's the next thing to do?
We multiply the coefficients by it?
Well, not yet. This 2, you can't really multiply anything because that is 3 to the 4th power. So you have to figure out what that is first. Remember your PEMDAS. Probably learned this back in 4th grade.
Yeah.
Okay. That's parentheses first, exponents second, multiplication, division, addition, subtraction. So we're looking at a lot of parentheses and exponents. So we want to do that first. What is 3 to the 4th power?
3 to the 4th power is, so it's 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is
81. Notice that it's the same as 9 squared.
Okay.
In other words, it's the same as 3 squared times 3 squared. That would be 3 to the 4th, right?
Yes.
Well, that's 9 times 9. 81. Okay.
Okay. Easier way of doing it.
81 times 2 is 162. Now, what's 3 cubed? You already said 27. 27 times 5 is 135. Minus 12 plus 8. Let's see, that's 27 minus 12 is 15 plus 8 is 23. That should be our answer.
So the way, yeah, so that's synthetic division, but.
Well, it's not really synthetic division.
Yeah, because the way I did it.
You don't need to use synthetic division when you say evaluate this function at a certain number.
Yeah, because the way that I did it on the paper looks different, but I got the same answer. And
it's going to be completely different. First of all, you might use synthetic division if you were trying to figure out whether 3 was a 0. Okay?
Okay.
In other words, if I substitute 3 for x, does this whole thing equal 0? If it does, then 3 is a 0. And if I was checking various numbers to see whether they were zeros or not, I would use synthetic division. Now, synthetic division isn't a lot different than what I did Here, I'll show you what you have on your page, and let's just make sure we're in agreement here. What you're going to do is divide by the 0. Well, that would be 3. And you're going to list at the top your coefficients only. And you're going to allow for every power of x. We are missing an x squared, so we're going to stick a dummy variable, 0, in there for x squared, and then minus 4, and then 8.
Yeah, so it's not just like x squared. So if we were missing, like, let's say there was a x to the 4th, but no x to the 3rd, but there was an x squared. So we would put a 0 in between x to the 4th coefficient.
Okay. In other words, it has to have a coefficient for every power of x in order. Okay? So
and then
if there is no power of x, then put a 0 in.
Yeah, so I'm pretty sure I know how to go from here with the synthetic division. You bring the 2 down and then multiply it by the 3 and then add it to the 5, and then whatever you get from that, you multiply it by the 3, add it to the 0. Yeah, so I know how to do that. From this point, what I need to know is it has a few questions, A, B, and C. It says, is this a factor? Yes or no. List the coordinate point found for this polynomial and list the remaining polynomial.
Okay. Is it a 0?
Yes.
No, it isn't. There's one thing that's absolutely required for that to be a 0. And that is this last thing has to come out to be 0.
Got it.
It does not in our case. Incidentally, I made a mistake here. I forgot my minus sign right there. I was trying to figure out why I was so far off. Let's try this again, and we'll figure out what that remainder was. Two, 6, 1, 3, 3, 9, 5,
15, 23.
23. That 23, if that was 0, then this 3 would be a 0. There is something called the zero remainder theorem, that for a number to be a 0 of a polynomial, when you substitute or divide either one, your remainder has to be 0.
Got it.
So what this is doing, this synthetic substitution, is it's dividing that polynomial by that. Long division. And even if I were to do long division, I would have to allow for that dummy x squared.
So essentially, if it is 0, then it is not, or it is a factor.
It is.
Okay.
That's the only time it is. It cannot be a factor unless it is 0.
So and the only time I answer yes to that question is going to be when it comes out to 0.
Yes.
All right. That's just what I need to know.
Let me point one other thing out.
Okay.
These set of numbers you get down here, that is the quotient. In other words, my quotient is 2x cubed plus x squared plus 3x plus 5 with a remainder of 23 over x minus 3. And I don't need to use r. I can just say plus. So your second and third questions were what?
List the remaining coordinate, and I see that that's the remaining polynomial that you just gave me. But what's the coordinate point found? How do I find the coordinate point within the polynomial?
Not sure what they mean by that.
It says list the coordinate point found for this polynomial.
Don't know what
Maybe
they mean by that.
our intercepts.
Well, you have y-intercepts, you have x-intercepts. This is the y-intercept right there.
Yep.
Because the y-intercept means when x is 0. So it's clearly going to cross the y-axis at 8. So if I had to draw it, the only thing I know at the moment is that it crosses there, right there. We're looking at a quartic. So it might do something like that, have a couple of loops in it, and go like that. Cortex are going to have you discussed left-hand end behavior and right-hand end behavior and stuff like that?
Yeah.
Okay. I don't know what it means by what are the coordinate points.
I can follow up with that with her tomorrow. We have a study hall period. I have a study hall period with her, so I can just ask her that. So we can move on to the next category.
Okay.
Which would be just simply factoring and solving polynomial functions. Just going over that a little bit, just for a couple problems.
Okay.
Which would be, this one is g of x equals x cubed plus 5x squared minus 9x minus 45.
First of all, let me say that this is a cubic. Cubics are notoriously difficult to factor.
Okay.
You can take your quadratics and put them on steroids and it's still not as hard. There is a quadratic formula that will factor any quadratic. There is no such thing as a cubic formula.
Okay.
So 99% of cubics are going to be 20-minute problems. I can show you how to factor them, but it's way beyond what they're teaching you at this point.
Okay.
However, about 1% of cubics fit into a very small category that lend themselves to grouping. And I can solve this by grouping. And by grouping, I mean I'm going to group the x cubed and the x squared term together, and then I'm going to group the last two terms together. So
Okay.
I want you to do this because it gets a little tricky. By grouping them, I mean I'm going to put parentheses around them. What goes in that second set of parentheses?
Negative x minus 45, or actually, it doesn't it flip? Well, never mind. That happens after.
The most important thing is make sure that it's exactly the same. You cannot change it. So what has to go in the parentheses so that it's exactly the same as what we started with?
9x minus 45.
Now check that and see if it's exactly the same. It's not.
Yeah, because if you multiply the right side,
the negative sign has to distribute to both terms. So that would end up being plus 45. So what do I have to do? I have to do plus 45. Now if you check this row with this row, you get identicalness.
Okay.
And that's very important. You can't, because all I'm doing is when I'm grouping, I'm not ever changing the function. You can't change the function. I'm just rearranging it. I'm putting parentheses around things.
Okay.
Okay, but that second line is now identical to the first because that negative sign has to be applied everywhere. Now, the second step, once you've done the first step properly, which is to group it, Now factor out the greatest common factor of each set of parentheses. What's the greatest common factor in the first set?
X, right?
No, it's actually x squared. Greatest common factor.
Okay.
I can take an x squared out of both terms. And by that, I mean I can divide both terms by x squared. That's all that means. I can divide both terms by x also. So x is a factor, but I want the greatest factor. That's x squared. Okay, what's left over after you factor out x squared?
I'm not sure what would happen when you divide x cubed by x squared, but I do know that it would be plus 5.
Subtract the exponents when you're doing division.
Okay, so just x plus 5.
Okay. Now do the same thing over here.
9. So it would be x plus 5.
Now, the secret on these problems is making sure that is the same as that. If
Okay.
they are not the same, you can't go anywhere from here.
Yeah.
And if you make that initial mistake, they're not going to be the same. This would end up being x minus 5. And so if you find this term on the right different than the term on the left, you know you've made a mistake.
Okay.
Go back and start from the beginning. Because the next step involves factoring out the greatest common factor from that row. What is that?
From the both underlying portions.
Exactly. It's a in other words, you're not used to factoring out binomial terms. You're used to factoring out monomial terms. This is probably the first time you've ever seen where you're factoring out a binomial term. What's left?
I'm sorry, I lost my train of thought.
Okay, so what we're doing is we're dividing that term by x plus 5, and we're dividing that term by x plus 5. So what?
Okay, so x plus 5 is the greatest common factor, obviously, because they're both x plus 5.
So it leaves x squared
Minus 9.
Minus 9. Now, that can be further factored. Notice that x squared minus 9 is the difference of perfect squares. How does it factor? This is why factoring is so important, is that all higher math depends on the ability to factor. How do you factor difference of perfect squares?
I am not entirely sure.
It's the square root of this minus the square root of that. In other words, x minus 3 times its conjugate, x plus 3. In other words, this is the only one you have to figure out, and then the second term is automatically the conjugate of the first one.
Okay.
Okay? Now, I have 3 linear factors. That's 3 solutions. What are my 3 solutions? X equals what?
X equals 5, x equals negative 3, and x... Well, actually, aren't we supposed to set them equal to 0, or is that not a step?
No, I'm glad you caught it. I was going to wait till you were done to correct you.
Okay. Negative 5, 3, and negative 3.
Good. And that's solving the problem.
All right. So that's all I need for that category. I just...
Now, like I said, if you change that to a 44, now it's not going to work. Here, let me explain just one thing that I hadn't really explained yet. And that is that for grouping to work, you can spot it instantly, whether it's going to work or not. And what it has to be true is these coefficients. The coefficient of the first two terms is 1 over 5, right?
Mm-hmm.
Has to be the same as the coefficients of the last two terms. Minus 9 over minus 45, which is also 1 over 5. That's how you tell whether grouping can be used.
Okay.
Is that ratio has to be the same as that ratio exactly. Can't be different sign, can't be different number. So if I change that to a 44, then grouping doesn't work. Now I've got a 20-minute problem on my hands. As long as grouping works, you can work it in about a minute. And that's the only kind they're going to give you at this stage of your math learning.
Okay.
You've not gotten to precalculus yet, which is where you learn how to do it if that is a 44. But all right, got 10 minutes. What else you want to go over, Nathan?
So let's do this category. I can write the polynomial function of least degree given the zeros.
Okay.
So for the first one, we have -1, 2, and 4.
What does that tell me the linear factors are? The linear factors, think of the last problem. Your linear factors were x plus 5 times, so what was your 0 minus 5, right?
Mm-hmm.
So if the 0 is minus 1, what is the linear factor?
1.
Plus 1. If the 0 is 2, what is the linear factor?
X minus 2.
Times?
X minus 4.
So they're saying that those are the three factors. Multiply them together, you'll have your polynomial. Now,
All right.
we want to do this at least once because this is not necessarily trivial. Multiply the first two together by foiling them. What do you get?
X times x is x squared. X times -2 is -2x.
Okay. On.
1 times x is x, or 1 is just x.
I'm going to combine those last two, come up with minus x, okay?
And then 1 times -2 is -2.
Okay. So that's the result of that times that. Now we got to multiply that times that. So FOIL doesn't work here because FOIL only works when you have a binomial times a binomial. But what foiling really is every term by every term. And that's what I prefer to teach people is ET, ET. Every term by every term. In other words, start from the left, multiply that, add it together, then go to this term, multiply that, add it together, and then go to the last term, multiply that, add them all together. So let's do it. What do you get?
So x squared times x is x, just x squared, right?
X squared times x. You got to add the exponents.
X cubed. And then x squared times -4 is -4x squared. -x times x is -x, so minus x.
Add the exponent.
-x squared, and then -x times -4 is 4x. -2 times x is -2x. And then -2 times -4 is +8, so +8.
Okay. What you always find out in these situations is there's only one of those, one x cubed, and there's only one number. And everything in between needs to be combined. So combine those two terms. How many total x squareds do we have?
We have x, we have 4, so, or 2, so we have x, it would be x to the 4th. So 4x.
You're using multiplication with subtraction. When you are subtracting or adding, I've got minus 4 apples and minus 1 apple. So I got minus 5 apples. I am not multiplying. It's only when you are multiplying that you add the exponent.
And then just...
An apple is equal to minus 4x squared. Well, minus x squared. That's my apple. I got 1 apple there. I got 4 of them there. I got 5 apples.
Okay.
Same thing, what do I get with the x terms?
Plus 2x. And then plus 8, and that's the finished.
And that's the... They said they wanted a polynomial of least degree, right?
Yes.
Okay. Well, it turns out that that's the least degree one. But I'll give you another one that also has those 3 zeros. In other words, I can just multiply this by any number I want.
So I see it's just the least degree is the most simplified.
Exactly. In other words, no coefficient in front of the x cubed term if you don't have to have one.
Okay.
Okay. But yeah, any multiple of that also has those zeros. Notice that I could have 9 times that. And if it's equal to 0, I can divide both sides by 9. So that's what they mean by least degree, is that coefficient is equal to 1 in the first term.
Yeah.
All right, we got a few minutes. You got one more?
Yeah, so it says write a cubic function in standard form that passes through these coordinates. We have 3, 0, -1, 0, and 6, 0. And then it says that has a y-intercept of 0, 36.
All right. So what we're looking at are x-intercepts.
Okay.
All right? In other words, the graph has to pass through that point. That is 3, 0. Also has to pass through that point. That's -1, 0. Has to pass through that point. That's 6, 0. And it has to pass through this point, which is 0, 36. Okay. So if I know these are 3 factors.
So I just, okay. So isn't it x -3, x plus 1, x minus 6?
Okay. Now, we don't have enough time to do this multiplication. So I'm just going to show you what happens. Okay?
Yeah. Okay.
I can tell what the last number is going to be. The last number has to be that times that times that. It's 18. I also know what the first number is going to be, or the first term in the final polynomial. I mean, you get it from this times that. So it's going to be x cubed. So I know this much. Okay? There's also going to be all this stuff in between. So the fact is, if this was my answer, what would my y-intercept be?
Well,
Remember, your y-intercept is when x is equal to 0. All the x terms are going to drop out. So what would my y-intercept be?
would it be 18?
Yeah. And yet they're telling us that the y-intercept is 36. So what do I need to do to this function?
Well, it needs
I
to
can multiply it or divide it by anything I want.
be 2.
There's your function. Got to fill in all the missing parts.
By foiling.
You got to, well, FOIL it or ET, but you got to multiply those three together. You're going to end up with a polynomial that begins with x cubed and ends with 18. And then you're going to multiply every term by the number 2 so that your last term is 36.
But even though that'll make there be a coefficient in front of the x cubed.
Yes.
Okay.
Because this is not a problem asking for the least degree or anything.
Exactly. The least degree would be this one here.
Okay.
So they're structuring it a little bit differently by telling you what this last number has to be. And what that means is you find out the least degree and you multiply it by whatever number you need to multiply it by to make that 36.
Okay.
Nathan, I got to run. I do have a 4 o'clock. Well, I'll talk to you.
All right. All right. Thank you.
You're welcome. Have a good one. Bye-bye.
You too.